This is day one notes for thermochemistry, and today we're going to talk about heat and temperature or energy conversions. So thermochemistry is the study of heat changes that occur during chemical reactions and physical changes of state, so going from solid to liquid to gas. Thermo, like thermometer, measures temperature, so you can think of thermochemistry as being the chemistry of heat changes in temperature. Energy is defined as the ability to do work or supply heat. So we can measure these units, how much work can we get out of something, or how much heat is supplied. Remember, we had kinetic energy. We talked about potential energy. We have heat, and then we have solar energy. There's nuclear energy, wind energy, sound is a form of energy, and magnetic energy. So these are all the different forms of energy. We've already talked a little bit about, a lot about kinetic energy, a little bit about potential energy. We're going to focus in on heat in this chapter. Eventually we'll get to nuclear. So heat is going to be symbolized by a small letter Q, and that just means a form of energy. It flows from warmer objects to cooler objects. If two objects come in contact with one another, the heat is going to move from the warmer object to the cooler object until they're both at the same temperature. We could say that they've reached a heat equilibrium. When you add heat energy, molecules move faster and faster, and then the average speed of those molecules increases, so the temperature increases. Remember that temperature is a measurement of heat. Increase heat, increase temperature. Chemical potential energy is the energy that's stored in chemical bonds. This is going to depend on the types of atoms that you have and the arrangement of atoms. And remember, some bonds are stronger than others, and some are weaker, so that's going to have different amounts of potential energy. In a chemical reaction, either potential energy will be converted to heat, which means that the heat is given off, which means your reaction will feel hot, and this will be exothermic. Like the hand warmers, that potential energy was converted to heat, which was given off, so the hand warmer warms up. You can also have the situation where heat is absorbed and converted back into potential energy, which means that this reaction will feel cool, and this would be an endothermic reaction because the heat is going into the bonds. And we're storing the energy in the bonds would be potential energy. If you remember my example of the can that rolled away and then rolled back, we can convert energy into kinetic energy, and then it's stored in potential energy when the rubber band was coiled up, and then it was released back into kinetic energy. So we can think of heat as being used in the same way. The law of conservation of energy says that energy can neither be created nor destroyed, only converted from one form to another. Different units of energy, some of these you'll be familiar with and some you won't. The first one is joule, and we're going to symbolize that with a capital letter J. And then calorie. Now, there are different types of chemistry calories. CAL is a chemistry calorie. CAL with a capital C is going to be a food calorie, and you'll see that they're worth different amounts. So little c, chemistry calorie. Big C is the food calorie that you're familiar with on packages. 1 food calorie equals 1,000 chemistry calories. So you can see that when you're eating the calories in a candy bar, we would multiply that number by 1,000 to get chemistry calories. 1 calorie is going to equal 4.184 joules. So again, you can see that we've got some conversions coming up here. We can use joules or we can use calories. And again, we're going to be using these two right here. So let's practice doing some conversions. How many calories are in 287 joules? We know we've got 287 joules. We're asked to find calories. This is just a dimensional analysis problem. We've got joules on the top. We look at our periodic table, and you'll see that there are 4.184 joules per 1 calorie. Put that in the calculator, our units are canceling off, and we'll get 68.6 calories. So this is just the same way you would set up a pressure conversion or any of the other conversions we've done. How many kilojoules are equal to 1,478 calories? There's our known and our unknown. Now, notice that we've got kilojoules, so you're going to need to use your periodic table to see that 1 kilo is 1,000. So we've got our known, and now we're going to convert that into joules. So 1 calorie equals 4.184 joules. But we're not quite done yet because we need kilojoules. So we need one more conversion factor. There are 1,000 joules in 1 kilojoule. And now we're ready to solve our problem. And you'd have 6.184 kilojoules.
Good morning. It's response time. Faculty, at this time, please release